Hello Psychics, and as you can see, I'm at CERN today. I'm here participating to the EOS workshop that is part of the Tech Storage Week. And I'm here to get the latest news on storage technologies. The idea is to bring, helicopter, back into what we saw last time. So we have this interlink software that is capable of spawning containers everywhere. We want to bring data with us. So for example, you have a VM, you bring up interlink there, you send a container, and then you get all the stuff you have in your home directory. That is the cool stuff that has been shown yesterday, and I'm going to talk with Hugo. He's going to tell us how we can leverage Reva to get a whole bunch of stuff in accessing and transporting and interoperate our data.
Because this is true for interlink, but also for many situations where you want to bring your data in a distributed system.
Hugo, thanks for joining. The idea here is to understand what can be used from the Reva perspective in terms of data management. So why we are talking about Reva. Yeah, I saw the demo yesterday. It was pretty awesome. So let's take a look at what Reva is, first of all.
Okay, so thanks, Diego. So Reva is a daemon written in Go basically. It's a gRPC server and an HTTP server. It's optimized for high performance and scalable access to data repositories. We actually support two file systems, EOS, which is the CERN disk storage flagship basically storage backend, and also FFS, because we see that there are other institutions basically that use FFS because it's more available basically. And yeah, so basically Reva is a demo that connects to these storage systems. It's a highly extensible system because we have a plugin architecture that was developed by one of my colleagues, Maria. And this is really nice because it's really extraordinary because you can easily just customize a binary. You can have your
The idea is that you have really a binary.
Yes.
So it's everything Go, it's portable,
it's basically single binary. We support basically architecture supported basically on the Linux operating systems. We don't do basically for Windows yet, and I don't know if we will plan to do so. But the idea that you get one binary, you run this daemon basically, one binary, and you have everything needed basically to export the data set that you have on your underlying storage. And for the plugin architecture, you basically define your own repositories in your own organization. And when you run Reva, you basically pass a flag specifying basically, okay, I want to build the core with these plugins. And yeah, that's how it works.
and you can stack more than one plugins, right? So
Yeah.
you access to, I don't know, I need single share, but I need also to access this data in some other ways. I can stack one on the others and have a single entry point for that.
Yeah. For example, like some plugins that people have developed are like specific plugins for authentication. Currently in the core we support basic authentication, OpenID Connect, and LDAP and Active Directory basically for getting user information and groups. But also people have basically created their own plugins to connect to their internal authentication systems. And for example, for Sandbox, we have our own way to deal with workspaces, how to create the lifecycle for workspaces. So we have also our own plugins, and actually this is how we run the service CERNbox in production, which is the brand name for the Reva deployment at CERN. We run it with some custom plugins for our CERN specific infrastructure, and that's the good thing about it. You can basically just extend it to your needs.
Yeah. So I saw yesterday the example where you show that I can manage to access and to change or share files via web interface, but also at the same time you access an SSH UI and you can find the very same file there.
Yeah.
So that also very nice. And what about the authentication and the authorization? There are plugins also for that, and now you can map.
So basically, how authentication works in Reva is the following. We basically get an authentication request with different identities. For example, you can authenticate with basic authentication, or you can basically authenticate with some authentication provider that supports OpenID Connect. So we get basically the token, and then Reva, you can configure basically how to extract the username from the token. Like, you can choose the subject, you can choose basically other fields from the token description, and this is basically how to extract the username. Once you extract the username, basically Reva creates its own LGBT tokens, which are configurable also for the lifetime, and this is how the authentication works. How do we pass this web authentication, let's say, context or from this domain to the underlying storage system? We do it in two ways. For EOS, EOS is quite powerful and flexible, so you can specify that the machine where the Reva daemon is running is a trusted machine and can actually perform impersonation on behalf of the user. So you can, with OpenID Connect token, you get your username and we tell EOS, this is the username, I have validated the token, and now you connect to EOS with this token. But this is pretty powerful. And for ThefFS, what we do basically is something similar, but we use Unix authentication. So we rely on the fact that where the ThefFS mount is mounted, local Unix and group IDs are actually the same as running on the Reva daemon, and Reva integrates with ThefFS using the official lift.thefs bindings from the Thef library, and basically internally it takes care to make sure that connections are multiplexed and creating basically connections on behalf of the user.
Cool. So I think I can leave you link to important documentation and important presentation in the description. Yeah, thank you, Hugo. I think that's all, and it's very cool, and I'm looking forward to test it.
Thank you, Diego.